Today I'm going to showcase a few examples of how some companies are using the GPU and exploring the GPU to make our lives better. And they're solving problems that are related to big data. Now, to say that some of these companies are working on big data is an understatement. They're working on huge data. They're working on massive data. And they have to do it not as quickly as possible, because best effort is not good enough for them. Best effort in some of these applications basically is a fail. For most of these applications, and you know how consumers are, they want it now. They want more of it and now. And so for them, real-time response is really vital. Well, it's hard to go a day. It's hard to go a moment without Twitter anymore. Unbelievable. 500 million tweets a day. 500 million tweets a day, and they just got started because 2 years ago, there were only 50 million tweets a day. 500 million tweets a day. Crowdsourcing the information that's in this body of tweets is absolutely remarkable, and smart companies like Salesforce.com are scanning this data, the social landscape, continuously. They're scanning the social database of every country, of every social site continuously. This one's interesting. And so what they do is they scan the data for companies like Cisco and Dell and Gatorade, who wants to know how their brand is being perceived. If you launch a brand new product, you want to know how your brand is perceived. It's used by the Red Cross to get an early indicator of an epidemic, of people who are crying out for help. Using crowdsourcing information, they can have instant access to information and discover early indicators of future concerns. 500 million tweets. Now, of course, you're going to compare that. You have to look for something within those tweets. And so Salesforce.com at the moment has about 1 million keywords that they look for, 1 million segments, what they call segments or Boolean expressions that they look for. And they're comparing this 500 million tweets that are coming by all the time and continuously. There's no sense saving it because you're going to get more tomorrow. And it's just growing. There's no way you can save this information. It's like life. It's just going to happen. You're going to do something about it or you're not going to do something about it. So these 500 million tweets come by and they're comparing it against 1 million different keywords. And they're searching for events, indicators that these million keywords, these million things that people are looking for, brands or expressions, are found. That search has to be done as quickly as possible or the information becomes stale. Well, the folks at Salesforce.com realize the exponentially growing problem that they have. The number of tweets is going up. The number of social sources is going up. The number of customers is going up that are interested in this. And the number of things that they're looking for is going up. It's a multi-dimensional expansion, all probably growing exponentially. And so they had the courage to try the GPU. They were excited about it. They ported to it, and they got a 35 times speed up. What used to take minutes now takes seconds. What used to take minutes now takes seconds. As a result, they can really scale out this service and have a sustainable platform to do so for some time. Searching for events, things that are happening in society. Well, one of the best applications on the planet is Shazam. Shazam is for people who no longer listen to the radio but still love music. And you're no longer cool, and so you don't know any band names. The last band name you remember is Bee Gees, the Eagles, Styx. That's right, you know what I'm talking about. I'm talking about 90% of you in the audience. Foreigner, when we all stopped listening to music, but we still like music. And we just don't have time to keep up with the new bands. There's so many bands. And so now you hear great music, great song, you just go Shazam, and it tells you somehow, magically, what the song is. Well, I'm not the only person who loves it. 300 million people love it. 300 million users of Shazam. They're adding 2 million a week. That's not a business model, that's an epidemic. I'm sorry, Jason. That's a good epidemic. There you are. 2 million a week. And these 300 million people are asking Shazam to identify 10 million times a day. 10 million times a day. And what Shazam has to do is they have to search these 10 million queries each day, these songs. Here, take my song. What song is this? And they test it and they query it and search among 27 million other songs. And they're doing this before you lose your patience. And so it's got to come back relatively quickly. Pretty amazing stuff. Well, to help us talk to us about some of the amazing work that they do and how the GPU helps them do their work, we're really, where are you, Jason? I thought I saw you. There you are. Jason Titus, come on stage. Everybody help me welcome Jason. Jason, good morning. Good to see you.
Okay.
Well, you know, you guys, Jason doesn't do anything small. Before he worked on Shazam, he worked on Yahoo Mail and Messenger. Now, back then, he only had 300 million users. So he doesn't do anything small. So tell us, how did you guys discover the GPU? How are you using it? Mm-hmm. And how does music search work?
So we had an interesting challenge that was kind of shown in that chart there, in that as we get more and more users, and we went unlimited a year and a half ago, and the number of searches was growing rapidly, and we said, well, how can we constantly be adding new music into the system, increasing with 2 million new users a week, and somehow meet this computational load? Mm-hmm. Because we have to be. It's not a simple search. It's actually searching in a noisy. Find the signal among the noise and do it tens of millions of times a day. And so, sitting down with the architects and talking, what can we do to scale this and release all the cool features that we want to build? We said, we think we can do this with GPUs.
Now, thousands of people at any given point in time have asked you to do a search. Yeah. And those thousands of people are asking at any second in time, asking you to do a search. You've got to go into a database of 27 million and growing songs. How does that work? I mean, I can't even fathom that.
First, it's worth noting that last year it was 12 million. Right? So we're on the path of growth of content is immense. And it's also very, it's not really stable. For us, especially now, we allow people to tag television. You can tag any of 160 channels in the US. We've done big events like the Super Bowl. And that ends up being highly spike driven. So if you have 120 million people watching the Super Bowl, it all comes in at once.
It's not 10 million linearly throughout the day.
Exactly.
It's not 10 million linearly.
So the way we actually put that together is we do an analysis and come up with fingerprints of all of those 27 million songs and put together a database in memory that we can search at high speed. And then across all of the mobile devices that have our software installed, when someone wants to discover and engage with media, we generate a small little, say, 2K fingerprint and send that up to our server.
But that's interesting. But a song is like 3 minutes long.
Yeah.
And I've used Shazam in the beginning of the song, in the middle of the song, at the end of the song, and just that little tail, and it works.
Yes.
How is it possible that you guys find the same fingerprint irrespective of where the song is? Tell us the secret so we could start a Shazam.
So it actually...
That's what they want to know. I'm just asking on their behalf.
So from the beginning, we felt that we had to build something that would be essentially near millisecond accuracy, like a small number of milliseconds. So it's actually, for us, when we're looking at a 1 to 3 second sample, that's actually an eternity for us. What we want longer, the times we want longer samples is because people are talking over the music, you're in a crowded restaurant, and we need to get enough of the signal coming through in that sample to actually recognize it. But it ends up being, I can tell you, before we brought on GPUs, we again and again would say, hey, this is a great thing we want to do. We want to be checking a whole bunch of times. We want to add content from all around the world, all sorts of crazy features, and we kept coming back to, we'd love to, but we don't have the capacity. And so we decided we had to put that to rest once and for all and build a system that could scale to having 1 billion users using us constantly every day.
And so
we're
now
on
you
that
guys have
path.
ported to the GPU. How much capacity have you effectively amplified, or how much throughput have you?
It's hard to say. It's definitely while growing the load and increasing the amount of content, like more than doubling it. We also took our costs down to less than a third of what it had been.
Wow.
So and we see plenty of room ongoing to keep that path going. So we have. I can promise anybody who's a Shazam user that there will be very cool features coming soon that are empowered by all this. And also, we're hiring for folks in this room.
Okay. Well, if you like music, they're hiring. So now you have 300 million users. There's 6 billion phones in use.
Yeah,
Is that about right?
It's only the beginning for us. Like we're adding 2 million new users a week. We're happy about that, but we'd like it to be 10.
And there's 94,000 Indian movies alone.
Yes.
Right. And each one of those movies has 2,000 songs within it.
Yes.
And
I follow Twitter all the time, and I find
your market opportunity is quite large. Is what I'm saying.
We work hard. Sometimes I've seen things come across on Twitter like, why doesn't Shazam have more Malaysian folk music? And we're going there.
Let's go.
But there's a never-ending challenge for us. Turns out there's a lot of music in the world, a lot of television that people watch. But
that explains why it came back the other day, Clueless. Yeah,
exactly.
Malaysian folk music.
Right.
That's terrific. Well, congratulations, Jason. You guys have really done something great.
Thank you much.
All right. Thanks for coming. Jason Titus. God, it's so cool to work on something like that. So audio search, music matching. So we've got people matching people. We got people matching music. I think you also need to match images. Imagine if you were to type in F-150 for all of the press. If you type in F-150, it comes up Ford F-150, unfortunately. However, if you type in Ferrari F-150, you'll get a really, really sexy car. However, for a lot of search, it doesn't work that way. It kind of works backwards. What you see is you see a beautiful dress in a magazine, or you see somebody wearing a really cool jacket or whatever it is, and you want to take a picture of it. You would say, I want a jacket like that. I want a dress like that. And it goes off and it finds the store. It might even say what's the brand, and it'll show you examples of all of the other dresses that are kind of like that. That has the characteristics of that. Now, when we look at it as humans, somehow we recognize what are the salient characteristics of a particular image or a particular thing, and we can identify this is a like thing. Now, that image recognition problem is obviously complicated, obviously requires computer vision algorithms, and obviously valuable. We would love to be able to do things like that. Imagine the possibilities. And so there's a really cool company called Cortexica, and you can imagine why they call it Cortexica, the cerebral cortex, which is used for your vision system and for understanding what you're looking at. And what they're all about is to use a model of the human brain and using computer vision algorithms and a supercomputer effectively in the cloud, powered by GPUs, to do image recognition, image processing, and then image search. The technique is really, really fantastic, and it's really the next level. Now, it's not matching something exactly. It's not like here is a label of a wine, find me exactly that wine and how much it costs and what's the Parker rating, where to buy it. It's more sophisticated than that. It's asking for what is this dress? What are other things like this thing? It's also good at detecting, for example, things that are not straight on. So there are companies that would like to know how their brand is being used, how their logo is being used in a particular photograph, but it's not exactly straight on. Maybe it's on a T-shirt somewhere. Somebody is using the Tide logo without license in a T-shirt. Maybe you want to do that, and they somehow could identify that and notice that that's Tide on a shirt, in a not straight up angle. And so they can recognize things that are not precise. Let me, I think the best way to talk about it is to show it to you. I want to, where's Mike? Mike is on the other side. Mike Houston.
Good to see you, Jensen.
Good to see you.
So there's the latest issue of InStyle magazine.
Let's show these guys what you've been working on with the engineers at Cortexica. Now this is I see my name here on, this is my copy of InStyle.
Thankfully my wife
This
was
is the
kind enough to
spring
lend it to us.
fashion edition. There's 594 pages of ads. And let's see here. There's all kinds of great stuff. Let's find something. Oh, here we go. Who's that?
So I think that's Kate Hudson.
This is Kate Hudson. Can you guys see this?
So we'll
That's
show you on
the ground.
Camera. Here, turn the magazine back around for me.
Okay.
So now you guys
Okay,
can
that's
see.
Kate Hudson.
Kate Hudson.
And
so she's wearing an Ann Taylor dress, but.
and so for all of you, you're probably saying, "Well, that's a cool app. Get me a girlfriend like that." Is that what you're?
Yeah.
No, that's the next version.
Right. Well, maybe they can go
This
to that.
version says, "Get me a dress like that."
Well, there's that matching talk later.
There's that matching tag. You combine this with fish.com.
That's right.
You gotta
Okay.
get me.
So,
All right.
so what we're going to do is we're going to take a picture of Miss Hudson, and we're going to search through 800,000 tops and blouses at eBay and return. So we're going to crop in a little bit so that we can match the top. So it's a sort of a geometric pattern. So let's see what it's going to return to us. So it's going to go to a GPU server. It's going to generate a fingerprint from the server. And then it's going to begin returning matches. Now, the goal here is not to find an exact match. It's to find things that are similar that you may be inspired by that are on eBay.
Wow.
Right? So it returned a bunch of geometric patterns. So you got some leopard prints. You got some floral patterns. If you notice, there's in her dress, there's a little bit of a sort of flower on the side. And so it sort of matched a flower pattern. But you also got some of the other sort of geometric frequency patterns, right? So
Well, suppose you have an image of a particular type of pattern that you're interested in. It could be a floral, it could be Asian, it could be Argyle, or
yeah.
right.
So here's a bunch of patterns. So why don't we try the floral pattern? Okay. So sort of Asian style illustration of a floral pattern. So the hope here is that it'll go off because it's learned databases and it'll understand that, well, maybe you want floral patterns or maybe you want something that's similar designs. Right? So if you notice, it's actually picked. So if you look at this shirt, right, it's picked up a floral pattern from the shirt. But the other fascinating thing is it's actually picked up some of the stylistic cues as well, right? So it's not just, sort of base patterns. It's things that intentionally look similar so you can be inspired by and find things at eBay. So again, it's going through 800,000 tops and blouses, and the turnaround time is within seconds, right?
So you could imagine this being used for example, art. I see a piece of art. I don't want exactly that one because that one says on the bottom Picasso.
Right.
Right? And so, but I would like something like that. You could take a picture of that. You can go to eBay, and it could come back and give me a whole bunch of images of art like that.
Right. So you can do things that are actually hard and abstract, right? So let's look at this one. I mean, how would you describe that weird, dotty, speckled thing? So
astrophysics. That's how I describe it.
Astrophysics. So let's see what's going to return. So it's a little dangerous because this one's a little bit more wild. So it actually returned sort of a speckly dot matrix pattern. It's a reasonable match. But again, it found some polka dot patterns. It found things that are somewhat related and similar. And so you can go and click on these. And eventually in the full app, integrated with eBay, you'd actually be able to just go to the Buy Now button and actually buy what you want. So whatever
that's
you're inspired
fantastic.
by. So let me show you one more. So Pinterest is really popular. It's sort of taken over how people sort of do wants and wishes and how they like things. And so people build these pages. And so I actually pulled a page down on celebrity fashion. Okay. So let's take a look at one here. So this is Sarah Jessica Parker. Right, she's up in all the fashion blogs all the time. So if we kind of zoom in.
Don't get it. I know.
So again, it returns sort of floral prints, but what's fascinating is you see that red stripe that kind of goes across the top.
Yeah.
So you notice it's picked up things that instead of just being black and white, also have that color characteristic in them, right? So there's the sort of zebra print that has the leopard overlay on it, right? But there's also, a dress that has, red sprites on it. And if you look at this dress here.
Oh, look at that. That's cool.
Right, it's picked up that base pattern. So again, it's about finding things that are similar, they may be inspired by to buy, and then taking you through to a shopping experience so you can actually purchase that directly from somebody like eBay.
Wow, this is going to take shopping to a whole new level.
Yeah, it's a different
All right,
world.
Mike, good job. Thank you very much.
Thank you,
What do you guys think? Is that amazing? So you got all these GPUs up in the cloud. You take pictures, you throw added images, and it comes back and show you things that are like things from other websites or other stores. Visual search. Visual search obviously is founded on a lot of image processing technology, and this is one of the areas where the GPU really rocks and rolls. And we're going to see now that more and more people are experimenting with using GPUs in the cloud in these massive data centers because it does image processing so much faster, which is a relatively obvious observation. And we have so many people uploading images now. You got 6 billion phones. People are taking, just uploading to Facebook alone, about 300 million photographs a day. Now today, most of these websites are social and photo sharing websites are really just pointing you to the photograph. And oftentimes what they have to do is they have to, what they call ingest it, load it in, change the resolution, so that they could store it in a smaller form factor, so that they could reduce the amount of storage. But we don't have to do that. We don't have to do all that. We don't have to do all the pre-computing so that if you were to access that photograph again, that the data center could provide it as quickly as possible. We could ingest, resize, re-encode those images so much faster now than when you add a GPU to a CPU, that the number of servers, these hundreds of thousands of servers that are running 24/7, uploading images, uploading videos, each minute, there's 72 hours of new YouTube videos being loaded. Now, in the future, you want to search against that YouTube video. Somebody somehow used a copyrighted content in a home movie they made, and they're making a fortune on that. It would be good for the web crawler to somehow detect or extract that this particular logo was used, and they could decide how they want to approach the creator of the content. Image processing is something that the GPU does really well, whether it's in computer vision, image enhancement, motion detection, object detection. The speed up by adding a GPU is really quite spectacular. And so we're seeing a lot of developments in this area, and we could take a lot of load off of the general purpose data centers by adding GPUs to them. Not only will we reduce the load, but we will also increase its capability to do other things like video search, like audio search, like tagging and such.